So this is the example calculation on page 88. I'm going to go through it with you now. So usually you will have to find this piece of information from a paragraph of stuff or within questions. And you should always write out a little table for yourself. So it can be simpler than the one I have here. Just go AB for acid base, and then you just have a V, an M, and an N. And if you need to line it up, you can, not necessary. And then you're finding the information from your question. So I'm going to read across the titration results line. The rule is for the volumes that you have to have plus or minus 0.1 centimetre cubed, which means this cannot be used. She will put that in, and she expects you to understand that I'm not using this number, and you have to get an average of what is left. So it just happens because these are the same number, they are 20.5 is my average. So I fill that in. I'm still reading across the line going this way. The next thing I have is 25 centimetres cubed of base. I have 0.1 big M moles per litre here. And now I go and look at my equation, and my ratio in this instance is 2:1. So 2 HCl's to 1 Na2CO3. This sentence here tells me the question mark, the thing I'm trying to find out, which is the concentration of acid. So that's my question mark. And you should nearly always have a gap either here or here. And if that's the case, then the other side is your way in. So I asked you the last day, highlight the way in for yourself so you know this is what we're going to do. There will be scenarios where both of these boxes are blank, but there will be an extra info. So there's no extra info for this question, but in future, if there's extra info in the question, here's where you would write it. Okay, so the piece of maths that we're going to use is called first principles. We're finding concentration via first principles. And essentially, the first principles works on the fourth triangle. So we're using the fourth triangle on each side. V over 1,000. But we are not using it all in one go. We're breaking it up. So we are going to start with our concentration in moles per 100 litres, which is the 0.1. We are going to find out how many moles there are in 1,000. So every time we go down the W, we are dividing. And we're going down here. So we're going to divide by 1,000. Every time we go up a line, we are going to multiply. So we're going to go from 1 to whatever our titer volume endpoint is. So we'll be multiplying by the titer volume on that side. We're then going to use our ratio, which in this case is going to be 1:2. And we're going to take that titer volume and find out what is in 1 centimetre cubed. So that is a division again. So divide by our titer volume. And then finally, we're going to go from 1 centimetre cubed all the way up to 1,000, which will be multiplied by 1,000. Okay, so in this case, this side is our base detail. This side is our acid detail. And I'm going to show you to you now broken down bit by bit. So our concentration of sodium carbonate was 0.1 M. That means 0.1 moles per 1,000 centimetres cubed. And that's our starting point. So we need to find what is our moles in 1 centimetre cubed. So that's relatively easy. It's 1 divided by 1,000, which is going to give us 1 by 10 to the minus 4 moles per centimetre cubed. Okay, so we've just done this step. We've gone down, we've divided by 1,000. The next thing we're going to do is figure out what is the moles of Na2CO3 that's in our titer volume. So that is going to be multiplying the 1 by 10 to the minus 4 multiplied by our titer volume, which in this case was 25 centimetres cubed. And when we do that, we're going to get 2.5 by 10 to the minus 3 moles. And that is in 25 centimetres cubed. And I always put the words TV. So in this part, we've gone from here to here, and we've multiplied by our titer volume. We're now going to go across where we use our ratio. And the ratio in this instance was a 1 is to 2. So we have to turn 1 into 2. We have to multiply 2 by 5 by 10 to the minus 3 by 2, which is going to be equal to 5 by 10 to the minus 3 moles, and that is in our acid titer volume, which is the 20.5 centimeters cubed TV. So here's what we've done. We've gone across here. We've used our ratio, which was 1:2. Here, we've just gone across using our ratio. So our next step now is we have to find how many moles of hydrochloric acid are in 1 centimeter cubed. So if it's 5 by 10 to the minus 3 and 20.5, we have to divide it by 20.5 centimeters cubed to get 2.4 by 10 to the minus 5 moles per centimeter cubed. So in this case, we've gone down here now. So when we go down, we said it's a division, and we divide by the titer volume on that side. So in this case, the acid. The last bit that we're going to do is we're going to find our moles in 1,000 centimeter cubed. So if it's 2.4 by 10 to the 5 in 1 centimeter cubed, I have to multiply that by 1,000 to find out what is in 1,000 centimeters cubed. And that is going to give me 0.24 moles in 1,000 centimeters cubed, which can be written as 0.24 big M. So in this case, we've now gone over here, we've gone up, and we've multiplied by 1,000. We're not done. So this gives me my concentration in moles per litre. This is a final answer. Usually if you have to look back at your original table back here. So here I have, this is 3 significant figures. That's how many significant figures I can have in this final answer. So there's only 2 in this answer, so then that is that done. The next thing we have to do is we have to convert the moles per litre into grams per litre. So moles into grams, there's only one triangle that we can use, and that's going to be our mass triangle. So moles over here and molar mass over here. So I now have, it's the molar mass in this case of HCl. So H is equal to 1, Cl is equal to 35.5. My molar mass is going to be 36.5. So if I'm filling in my triangle, I now have 0.24 over here multiplied by 36.5. And when I do that lovely piece of maths, I am going to get 8.76 grams. That is 3 significant figures. And so ends the maths. Just to say, if you go back and you look at this now again, we divide by 1,000 always on one side, we multiply by 1,000 on the other. We're multiplying by the titration value on this side, so the titration value of the base. We're multiplying by the titration value of the acid on this side, and we are using our ratio when we do the flat. I hope that helps.